All right, class. We are moving on to some new subjects. So, we're actually going to be doing exponential growth here in the coming weeks, but one of the initial lessons that they like us to do with exponential growth is called scientific notation. And basically what scientific notation is, well, with exponential growth, things get very large or actually very small very quickly. And so we like to be able to work with large and small numbers in a relatively easy manner instead of having to write them all out. And so we use this thing called scientific notation. And what scientific notation is, it's a form of writing large or very, very tiny numbers in more of a concise way. What it needs, the form that it has to be is you get some decimal number out here. So we're going to put in A. All right. So you have some decimal number out here, and that's always multiplied by 10 to some power of n being an integer. So it's got to be a whole number like 1 or 2 or negative 12 or 23, something like that. The number A always needs to be less than 10, but greater than or equal to 1. Okay, so A always needs to be written as some number in between 1 and 10. It could be 1. Now, so for example, what if I wanted to write, let's do 1,200,000 in scientific notation? Well, what I need is a leading number A that's in between 1 and 10. So the way I would write this is I would write, the first digit is a 1. So to write 1 and 2 in between this leading term in between 1 and 10 is I'm going to write 1.2. Now, that means I have to move the decimal point from here, and I have to move it up 1, 2, 3, 4, 5, 6. So to move the decimal plate up six places, well, if you move the decimal point up 6 places, that's going to be times 10 to the 6th. That's basically saying, all right, it's 1.2 times 10 to the 6th, which means I would have to get back to this number, I would actually have to move this decimal place to the right 6 times. 1, 2, 3, 4, 5, 6. And I would get back to this 1,200,000 number. So 1,200,000 written in scientific notation is 1.2 times 10 to the 6th. 1.2 being in between 1 and 10, and 6 being an integer. So let's try another one. A really tiny number like 0.000392 is going to be, well, I need to move the decimal place here, right? If I move it there, I'm going to be able, if I move that decimal place right here, that number, 3.92, is in between my 1 and my 10. So we get 3.92 times 10 to the, well, this time I'm not moving my decimal place to the left, I'm actually moving it to the right. So since I'm moving it to the right, instead of a positive number here, I'm going to have to move this 1, 2, 3, 4, 5 places. So it's 3.96 times 10 to the negative 5th. Or, oftentimes you'll see things written out like, okay, the population of the Earth. The population of the Earth is about, right now, it's about 7.53 billion. So 7.53 billion looks like that. So if this is 7.53 billion, how would we like to write that in scientific notation? Well, 7.53 billion is times 10 to the, well, how many times do I have to move my decimal places? Here's 3 more, and here's 3 more. So it's 9. 7.53 times 10 to the 9th. And so that's how you simply write numbers in scientific notation. Moving on from writing numbers in scientific notation, we should, in fact, do some operations. Let's do the easy one first. What if we want to multiply numbers in scientific notation? Well, if I want to multiply numbers in scientific notation, let's choose like 3 times 10 to the 4th, and let's just multiply that by 2.1 times 10 to the 6th. Well, multiplication, this is all one big multiplication. It's 3 times 10 to the 4th times 2.1 times 10 to the 6th. And since everything is multiplied, we can rearrange it any way we want. And the way we might want to rearrange this is say, well, I want the 3 right next to the 2.1. And then I want the 10 to the 4th right next to 10 to the 6th. And you know your exponential rules. If I have some number to a power times that same number to a power, like an x to the 4th times x to the 6th, you know that multiplying these things, what I would do is I would actually add my exponents. So in fact, this turns into 10 to the 10th. 3 times 2.1 is 6.3. So we get 6.3 times 10 to the 10th, and we're done. So that's multiplying in scientific notation. It could get a little bit harder, so let's try one more. Maybe 2 times 10 to the negative 4th. Then we'll multiply that by maybe 4.8 times 10 to the 2nd. No, let's go negative 6th times, we'll say 3 times 10 to the 2nd. Okay. Now this is a multiplication of 3 things, but again, you can do it in any order. So let's first take the 2 times, let's just do 2 times 3 actually, that'll be easier. Well, 2 times 3 is 6. Or in fact, if you wanted to, you could get out a calculator and you could say, okay, look, all I'm doing is I'm taking 2, I'm multiplying it by 3, and then I'm multiplying it by 4.8. So those were just the leading numbers, right? And my leading numbers come out with 28.8. So let's write that down. So I'm going to get 28.8 times 10 to the what? Well, how many 10s do I have? I have negative 4, negative 6, and 2. Well, negative 4 and negative 6 make negative 10, plus another 2 would actually make negative 8. So this is going to be negative 8 here. Problem is that this is not in scientific notation because 28.8 is not in between my 1 and my 10. So I actually need to move this decimal place 1 place over. But we notice since I'm moving it to my left, I need to add 1. So in fact, my answer is 2.88 times 10 to the negative 7th. And so that's how you multiply scientific numbers. Let's go on to division. So for division, let's try 5.2 times 10 to the 4th over 4 times 10 to the 2nd. Now, you can basically do the exact same thing as you did with multiplication. You can just treat your numbers. So 5.2 divided by 4. 5.2 divided by 4 is 1.3. And then you have 10 to the 4th over 10 to the 2nd. Well, with just like exponents, when you divide exponents, these exponents, you actually subtract them. So what's 4 minus 2? This is going to be times 10 to the 2nd. And we're done. Let's try another one. A little bit more complicated here. Let's try 4.8 times 10 to the, let's do 15th over 1.2 times 10 to the negative 3rd. Well, 4.8 times 1.2 happens to actually just be 4. Now, 10 to the 15th, but then I have negative 3 on the bottom. Well, a negative 3 on the bottom can be moved to the top, and so this is going to actually be 10 to the 15th on top with another 3, so it's 18. In other words, you take the top, you subtract the bottom, but 15 minus negative 3 is in fact 18. Just like here, 4 minus 2 was 2. So that's how you can get this. So you just subtract. So just like up here, when we multiply, we add our exponents. down here when we divide, we take our exponents and subtract them. So 4 minus 2, 15 minus -3. You always take the top and subtract the bottom. Let's do one more where we actually have to then correct for scientific notation. So let's say, so let's say I have 1.2 times 10 to the -3rd over 4 times 10 to the 12th. Well, 1.2 divided by 4 is actually just 0.3. So we have 0.3 here. Then we have 10 to the -3rd and 10 to the 12th. So -3 minus 12 is times 10 to the -15th. Problem is, 0.3 is too small. It's less than 1. So it's not in between 1 and 10, which means we now need to say, okay, we need to move this 1 over. Well, I'm moving it to the right, which means I actually have to subtract another 1. So this answer is actually going to be 3 times 10 to the -16th. And we're done. We've got one more thing, and it's called addition. We're going to try for adding scientific notation here. So let me get a new piece of paper. There we go. Okay, so adding scientific notation. So what if I have 4.5 times 10 to the 12th plus 1.7 times 10 to the 12th minus 3 times 10 to the 12th. Well, notice everything is in terms of 10 to the 12th. If everything's exactly in the same term, which is 10 to the 12th, we can actually add these. So 4.5, in fact, if you want to get out your calculator, 4.5 plus 1.7 minus 3. 3.2. Okay, so this is going to equal 3.2. Well, since everything is in the same exact term of 10 to the 12th, this thing is still going to be the exact same term for all of your scientific notation, in which case then your answer will be in that term. The next one, let's do one more here. Yeah, we got time. So our last one is going to be 5.6 times 10 to the 7th minus 1.3 times 10 to the 6th plus 5.2 times 10 to the 7th. Problem is notice, now we're not all in the same term. This is a 10 to the 7th, this is a 10 to the 6th, this is 10 to the 7th. So how do we make them into the same term? Well, why don't we, I generally, what you need to do is you need to make them all in the same term. I generally go down. What I mean by that is, instead of a 10 to the 6th, I want to write this, instead of a 10 to the 7th, I want to write it at my lowest. So every term is going to be in terms of 10 to the 6th. To make this 10 to the 7th a 10 to the 6th, I need to multiply one of the 10s over. And so that's why this becomes a 56. This remains 1.3. But this also becomes a 52. So adding these together gives us 56 plus 52 minus 1.3. That's 106.7. So we get 106.7 times 10 to the 6th. This is clearly not in scientific notation. So we need to take this decimal, and this time we're going to have to move it 2 places. And we're moving it 2 places to the left, which means we're going to add 2. So our actual answer is 1.067 times 10 to the 8th. And that's how you deal with scientific notation. We'll go over this again, but for now, try the homework, which I've assigned. Yeah, good luck. Thanks.